All right, let's talk about how modern software is really made. We're going from the basic building blocks all the way to thinking machines. This is the hidden story behind pretty much everything, from the app on your phone to the most advanced AI out there. So let's jump right in.
Okay, so let's start with a really big question. How would you build a robot's brain? I mean, really think about it. The code that lets it see, process the world, and actually move? Where do you even start? Do you just open up a blank file and stare at that blinking cursor?
Well, here's the secret. The big reveal that pretty much powers all of modern technology. You don't start with an empty file. You just don't. You never, ever start from scratch. The whole game is about building on top of work that other people have already done.
And that brings us to the first and maybe the most important rule of modern programming. Never start from scratch. Honestly, the best way to think about it is like building with Legos. You're not sitting there melting plastic to make your own bricks, right? No way. You grab the pieces that already exist and you put them together to create something totally new.
So, in the world of Python, which is what we're focusing on here, these Lego bricks have names. They're called modules and packages. A module, that's just a single file of code. Think of it like one very specific Lego piece. A package, on the other hand, is like a whole Lego kit, a box full of related pieces, all organized and ready for you to use.
Okay, so how do you actually get these pieces into your project? It's surprisingly simple. You use one little command, import. That's it. That one word is like a key that unlocks a massive universe of code that's already been written and tested by people all over the world. We're talking everything from simple math functions to mind-blowingly complex AI tools.
All right, so we get it. We can import code. That's cool. But what tools do developers actually use day to day to manage all of these different building blocks? Let's open up the toolbox and see what's inside.
You know, some useful stuff comes built right into Python, like a basic math library. But that's just the beginning. The real power, the game-changing stuff, comes from the millions, literally millions of packages that people have created and shared for free. So the big question is, how do we get our hands on all that good stuff?
And here it is. This command right here is basically a magic wand for developers. It's a tool called pip. You just go to your terminal, type python-m pip install, and then the name of the package you want, and bam! In seconds, you can download and install these incredibly powerful libraries, like NumPy, which is a powerhouse for scientific computing.
But wait, it gets even cooler. You got to keep things organized, right? Imagine you have two different projects. Project A needs an old version of a library, but Project B needs the shiny new one. If you install them both on your computer, they're gonna fight with each other. It's a mess. So how do you solve that? With something called a virtual environment, or VEnv. It's like creating a separate, isolated little sandbox for each project so their Lego pieces never get mixed up.
So what we're left with is this really simple but super powerful workflow. Step 1, you realize you need to do something, maybe analyze some data. Step 2, you use pipe to install the perfect tool for the job. Step 3, you import that tool into your code. And step 4, you build your thing. This cycle, this is the absolute heartbeat of modern software development.
Okay, let's take all these ideas and see how they stack up in a much more complex situation. Let's go back to our robot. Because applying these basic tools to something as intense as robotics, that's where things get really interesting.
See, in a field like robotics, you're not just grabbing those public Lego pieces off the shelf. You're also designing your own custom, super specialized bricks. You know, your own code for controlling a specific motor or processing data from a unique sensor. And you need a system that can manage both the stuff you downloaded and the stuff you built yourself.
So take a look at this. This is a simplified layout from a real robotics project. You've got your main package folder, and right inside is your custom code, that special Lego piece we just talked about. Then you've got a separate folder for your executable programs, and that's where the main brain of the operation lives. That's the program that's actually going to use your custom module.
Okay, but this brings up a really important question. When you hit run on your main program, how in the world does it know where to find your special, custom-made code? It's not something you downloaded with pip, it's just sitting there in your project folder. So, how does the system find it?
The answer is in a special configuration file. You can think of it like an instruction manual or an address book for your entire project. This line of code you're looking at creates something called an entry point. And it's basically just a little note you leave for the system that says, hey, just so you know, when someone wants to run the program I've named my_node, the code they need to start with is inside this specific file.
And this really shows the two ends of the spectrum, doesn't it? On one hand, you have the simple import math. That's like reaching into a toolbox and grabbing a calculator someone else made. Super easy, super useful. But on the other hand, you have this configuration file. That's not grabbing a tool. That's being the architect who's drawing the actual blueprint for the whole building, deciding how all the custom rooms and hallways you design fit together. It's the same basic idea, using code, but at a completely different scale.
So let's zoom all the way back out for a second. Everything we've just walked through, this isn't just some niche thing for robotics. This is it. This is the invisible blueprint that holds up pretty much all of modern software.
So let's recap this blueprint. First, you have reusable code in the form of packages. Second, you have a tool like pip to go out and get them. Third, you have clean workspaces using VNV so your projects don't turn into a tangled mess. And finally, you have those configuration files that act like the glue, wiring everything together into one cohesive working piece of software.
And this is why all of this matters so much. Without this elegant, layered system of reusing, installing, isolating, and configuring code, well, the incredible explosion we've seen in fields like AI, data science, and robotics just wouldn't be possible. It would be too slow, too messy. This system is what allows every new developer to quite literally stand on the shoulders of giants.
So I want to leave you with one final thought. This whole system, this entire philosophy of building on the work of others, it's really all designed to ask one simple question, not just to developers, but to you. What could you build if you never, ever had to start from a blank page?